Hello, in this video we're going to talk through Module 7 and the course pack. Throughout the video there's going to be a couple spots where I fast forward, or sort of for the sake of time I'll just jump ahead and write out my solution. So just be mindful of that, and when necessary just pause the video and then or back it up and sort of catch up with what I'm doing. So here in Mod 7 we're turning a corner and we're introducing a new idea that we'll be dealing with for the next couple modules. Specifically, we're dealing with mathematical models. And while that's kind of fancy and a pretty broad topic, there are a couple specific ones that we are going to focus on. You've already read in the e-text in the build-up to Module 7 that we're going to be focusing on two specific types of mathematical models, namely linear models and exponential models. What we'd like to do in Mod 7 is just go ahead and jump in and give it a shot. So we're going to start with an example where my friend Mark is going to be building some custom guitars. It says here that Mark sells each of his handmade acoustic guitars for $1,600, while each guitar requires $760 in supplies, and he's got a workshop that he pays rent of $485. So to start, we want to know how many does Mark have to sell in a single year in order to break even. To get started, I'm going to go ahead and define the variable x to indicate the number of guitars that Mark makes and sells. And then when we think about breaking even, we're just trying to get to the point where his revenue, the money he brings in, equals or balances out his costs. And so let me go ahead and set up a couple of expressions for each of those. Let's talk first about his costs. We know that he's going to pay $485 each month for rent. Since that's a monthly value, I'll multiply that by 12. In addition to that, though, he pays $760 for each of the guitars that he makes. So I'll take that 760 multiplied by the number of guitars. And if I add those two together, that should give me the total costs that Mark has to pay out. Mark's revenue is the amount of money that he brings in. And that's simply going to be that $1,600 that he pulls in times the number of guitars that he sells. And so then my break-even point is when these two things will be equal to each other. We'll actually use these two components in later parts of this problem in a slightly different way, but for now that's what we'll focus on. So I can actually set that up as an equation here, 485 times 12 plus 760 x equals 1600 x. Let me subtract 760 from both sides. And now I can divide both sides by this 840 in order to isolate x. I apologize that my 4s kind of look like 9s here. But let's go ahead and divide both sides by 840. Now, doing this calculation, I get an approximate x value of 6.93. The units here, x, remember, counts the numbers of guitars, so I don't think he can sell 0.93 of a guitar. So I'm going to go ahead and round up, and I'm going to say that he has to sell 7 guitars in order to break even. In the next part of the problem, we're going to build on that same information. This time we know that he is going to be able to sell 16 guitars. That translates directly into an x value. So specifically here, x is going to be 16. And then given that he sells 16, we just want to know how much money does he actually clear. What's his profit? Profit is built out of the two components that we identified in the previous problem. Specifically, profit is how much money he brings in, that's his revenue, minus how much money he has to pay out. So those are his costs. So if we wanted to, we could write a profit function. Let me call it capital P. My revenue is going to be 1600 x minus his costs. And let me go ahead and grab this entire expression for costs. So that's 485 times 12 plus 760 x. Simplifying that a little bit, I get this expression here for profit. His profit is going to be $840 for every guitar he sells, but then he has to subtract from that his overall costs, his sort of standard costs. So if we want to figure out how much profit he'll make using selling 16 guitars, we'll simply plug in x equals 16, getting a final profit value of $8,160. Okay, not too bad. But in this last part, it actually just asks us to kind of take a step back and say, does this seem like a viable income for Mark? Mark has 4 kids. His wife works, but I don't think he can really expect to provide for his kids off of 8,160. And so in the last question, maybe you can do some additional calculations to just kind of speculate how many guitars would he need to sell in order to end up with a reasonable annual salary. In the next example, we're going to use some similar calculations to what we previously did. This time we're dealing with a local retailer who's been advertising in Flag Live, and she's got some sales values sort of before and after she started advertising. So she's trying to measure the effect this advertising has had on her revenue or on her sales. The problem indicates that her sales have increased by roughly $380 per week since she began advertising in Flag Live. Her weekly sales were roughly 12,400 5 weeks ago when she began advertising. And so we want to know how much can she expect to make if this trend continues 8 weeks from now. It seems like the independent variable here is essentially time. To be more specific, I'm going to call my independent variable the number of weeks since she started advertising. And using that as my variable, then we kind of have this 12,400 as like a baseline value. So if I want to think of, maybe I can be more explicit here and actually define a dependent variable to be her sales. And then this 12,400 is like the initial value of that sales variable. We'll get into this notation a little bit more in subsequent examples. I'm actually going to call that y sub 0. This is like initial, in this case, sales, because that was the amount of sales before she started advertising. So then if I think about this 380, that's actually the amount that the sales are increasing every single week. So this is the amount that y will increase for one increase in x. And if you think back to the structure of a linear model from algebra class, you could actually recognize that as being the slope. So this is $380 per week. So notice that in that fraction of units here, my numerator is the units on y, and my denominator is the units on x. So then combining all this information, I could actually write out an equation here that says she's going to start at $12,400 for sales, and then her sales will increase 380 for every week since she started advertising. So this later we'll refer to this as like a general equation. And this equation allows me to input any x or y values as appropriate and then solve for what I'm missing. In this case, notice that she started 5 weeks ago, and then in addition to those 5 weeks, we want to project 8 weeks into the future. So we're actually going to use the x value of 5 plus 8, the 5 weeks from when she started until now, and then the 8 additional weeks from now until where we're trying to project into the future. So we'll be using an x value of 13. So we can plug in x equals 13 into my equation, and I'll get 12,400 plus 380 times 13. Doing some simplification, we expect her total sales to be 17,340 in 8 weeks from now. So that's 13 total weeks since she started advertising. This example demonstrates the structure of a linear model, and it kind of highlights the slope feature and then this initial value that we'll utilize in subsequent examples. For this next example, we're discussing a concert promoter and the number of tickets she expects to sell based on the amount of advertising she does. Specifically, it says that she expects 150 people will show up to a small concert even if she spends no money promoting it. But based on her experience, she believes about 75 more people will attend for every $10 she spends on promotion. Utilizing the structure that we saw in that last example, we could identify an initial value here. If we are using Y to represent the number of attendees, then her initial number of attendees corresponds to the number of people that will show up if she spends no money. And as indicated in the problem, she actually believes that 150 people will show up even if she spends no money. So we'll use that 150 as her initial value. The slope for this equation will be how much this Y value increases for some increase in X. Just to clarify, we're using X to represent the money that she spends on ads. And so her slope is captured by this last sentence here in the original problem, where it says that she believes about 75 more people will attend for every $10 she spends. So the structure of her slope will be an increase of 75 attendees for every $10 she spends on advertising. We can simplify that and write that as 7.5. It's not necessary, but maybe that'll help clean up the calculations in a sec. Continuing with the same problem, we now want to put the ingredients that we just identified together to write a general equation. I'm going to borrow my structure from the previous example, where I actually start with an initial value and then I indicate how much I increase from there as captured by my slope. And then I multiply that by the number of units, and in this case, whatever my X is representing. So using the ingredients that we identified a second ago, she'll have 150 people attending the concert plus 7.5 times X for an increase in attendees based on X, which here captures the amount of money she spends on advertising. In the next part of the problem, they give us a dollar value of 100. That translates directly to an X value of 100. So we could plug that directly into our general equation. I get 150 plus 7.5 times that dollars spent on advertising, which is 100. Simplifying, I get a total of 225. So I would expect that 225 people will attend if she spends $100 on advertising. The last part of this problem, we now have a goal of selling 1,000 tickets. That actually translates into a number of attendees, so that'll be a Y value. So if we plug that into our general equation from a few steps ago, I actually get 1,000 on the left-hand side equals 150 plus 7.5 X. Doing some simplification, I see that she should expect to spend about $113. Our calculation gives us $113.33 on advertising in order to yield that 1,000 attendees.